Hi there. In this video, I'm going to show you a very interesting AI agent for fraud investigation. And I'm calling this agent as FB.AI. So in this video, you will see on what is FB.AI, why it is useful, and then I will also show you a Python implementation of this particular agent. Now, I'm going to take a use case of financial fraud prediction in a banking environment. So generally speaking, the traditional machine learning process works something like this. You have some transactions, financial transactions, which has got information on the amount, the geography of the transaction, device, velocity, merchant, etc., etc. Now, this particular data is then fed to a machine learning model, and a classic machine learning, a popular machine learning model which is used is called as XGBoost model. Now, this machine learning model is going to output a probability of the fraud. And this probability, if it is very high, in that case, the transaction is classified as a fraudulent transaction. So, for example, if a probability of the fraud is more than 80 to 90%, in that case, it is a clear-cut case of a fraud. And in that case, the bank is going to classify that transaction as a fraudulent transaction. In addition, you also get some explanations, also called the SHAP explanations, on why the transaction is classified as a fraudulent transaction. But the problem comes when the probability of the fraud is somewhere between, let's say, 35 to 70%. So it's not too high and not too low. And this is what we call it as the gray zone. So all the transactions which fall under the gray zone require some manual investigation. So generally speaking, the machine learning model has till now seen only data which is structured data, such as the amount, geographical information, devices, merchant information, etc., etc. But it does not know all other data sources which are required for investigation, such as the document IDs, or for example, invoices, or even, for example, support history. So some human has to look into this additional data to conduct a thorough investigation to actually determine if the transaction which is in the gray zone is actually a fraudulent transaction or not. So a human reviewer, also called as a fraud analyst, is going to look into all these different data, such as the photo ID, the invoice PDF, the support history, and then it is going to manually review these cases and then determine if the transaction is actually fraud or not. So this investigation can take from minutes to hours per case, and Agentic AI solution or our FB.AI can help reduce this investigation time. And let us look into how this could happen. So in an agentic solution or the FB.AI solution, you can have an agent which is taking input from the machine learning model, and then it is going to use different tools. So these tools are going to basically gather the different evidences, such as the photo ID. It is going to also take into account the invoices, as well as it's also going to look into the customer historical data. And then based on that, it is going to apply reasoning. So reasoning is a way in which it is going to automatically come to the conclusion by looking at all the different data and also using the power of large language model. If the transaction is actually a fraud or not, in that case, it will deny the transaction. If it determines that even though the transaction is in gray zone, we can approve it. Or if it is still not able to decide, it is going to escalate it to the fraud analyst. So this particular process here, the investigation, collecting evidence is all automated. And for this reason, we can reduce the investigation time from hours to just seconds. So this is a very interesting way in which you can actually go from fraud prediction to fraud investigation and decision in a very, very rapid way. Now let me show you on how this FB.AI could look like from a solution perspective. So here we have all the list of transactions, and here you can see the transaction ID, you can see the merchant name, as well as you can also see the amount, as well as you can also see the country of origin. In addition, you also see the probability which is given by the machine learning model. So here, for example, the probability is 71%, which is not too low but not too high. So this requires some investigation. So let us now see on how our agent is going to help us investigate whether this transaction is fraudulent or not. So first of all, here you see the SHAP scores, which is given by the machine learning model. And you can see that the top reason why this transaction is classified as fraud is because of the amount, because of the distance from the home in kilometers, as well as the country, which is the origin, which is Nigeria, is also considered as a high-risk country. Now, let us activate our agent who is going to investigate this particular case. So the agent is going to read different documents. So here it has read the ID document of the customer, and then it has also determined that the photo match confidence is low. It also has gone ahead and read the PDF, the invoice PDF document, and then it has also looked into the customer history, and then it has also seen that there is no mention of any travel by this particular customer. So the agent has decided that the transaction is of high probability of fraud, and due to the significant amount as well as low confidence in the photo matching, as well as there is no mention of the customer traveling in the customer history, this is definitely a fraudulent transaction. So it is going to deny the transaction, and it is also going to give you a description or an audit trail of all the investigation which it has done. So as you can see that this investigation by AI agent is much more rapid, done in a very fast way, and it can help to reduce the human effort which is involved in investigating a fraud transaction. Now let me show you on how to implement this solution using Python LangGraph package. So here I'm in my Python notebook, and we are going to require different packages. But first of all, let us start with the traditional machine learning model on how it works. So here we are using a model which is called as XGBoost, which is a very famous machine learning model used by many data scientists. And let us also first look at some data. So here you have some financial data. So this data has got the transaction ID, the customer ID, the amount, the merchant category, country, device, etc., etc. And then you can use a machine learning model like XGBoost and start predicting if the transaction is a fraudulent transaction or not. So here you see the various probability of the transactions. Now, it will also give you these explanations on why a transaction is fraudulent or not. And this, we can use this SHAP library, which is going to help us do so. So here, for example, you see that the top reasons for a transaction to be fraudulent is the amount, the device new, and number of transactions in the last 24 hours. Now, you can also see a reason for a specific transaction. And here I've taken an example transaction, and you can see here that the top reasons which this machine learning model is identifying as the reasons why this transaction is fraud is the amount, is the number of transactions, and the device itself, which is considered as a new device. Now, you can also see all the transactions which are falling in the gray zone. So for example, here all these transactions, we are not very clear if this is actually a fraudulent transaction or not. So let us now see on how an Agentic AI solution can help automate this investigation. So here I'm creating some mock data. So here you have some mock ID scan invoices as well as customer history. And then let us now look into the agentic solution. And here I'm going to use the library called as LangGraph, which is a very powerful Agentic AI framework. So we need to first of all define various tools. So tools are basically functions which are going to get data from different sources. So here we have a tool which is going to read the document ID. here we have a tool which is reading the invoices, and here we have a tool which is reading the customer history. So as you can see that you can have tools which can also look into structured data, but at the same time, it can also look into unstructured data. Now, here you are defining various nodes which are required by LangGraph. So here we have a node which is going to give the final verdict, which is either approve, deny, or escalate. You also have the agent state, which is basically collecting all the information from various agents and nodes, which we are going to use in the LangGraph. You also need to define a node, which is our large language model. And here I'm using the large language model from OpenAI, GPT-4o Mini. Now here we are defining the agent node, which is basically taking the large language model and binding it with all the tools what we have defined earlier. You also need to define an edge, which is should the agent continue investigating or the investigation should end. Now here is your tool node, which is basically going to look into all the tools and start collecting all the information which is necessary for investigation. And then of course you have the decide node, which is going to call the verdict output node, and it is going to then make a final decision if the transaction has to be passed or not. So you can create a graph, and then you add all the nodes, and you also add this conditional edge, as well as you can now compile the graph. So the graph would look something like this, that the agent is going to call the different tools, and based on the output of different tools, it is going to send this information to a large language model, which is going to apply the reasoning in order to decide if the transaction is fraudulent or not. So this is pretty powerful, because here you see the tools is outputting information from structured data as well as unstructured data, and the agent, using the power of large language model, can automatically combine all these facts and then come out with an answer which is actually like a human investigating different data sources. You also have to create a system prompt, such as you are a fraud investigation agent, and use the available tools, and you also provide the different outputs which are provided by the machine learning model. You can then compile the graph, and then you will have your final rationale, which is going to decide whether the transaction is fraudulent or not. So for example, for one transaction, it has read few documents. So in the ID document, it has found that the photo match confidence is low. It has also looked into the invoices. It has found the merchant, the amount billed, the shipping country, as well as it has also looked into the different customer history. And then it has decided to escalate. And it says that the rationale is that the transaction has got red flags, such as including a high-risk country and a low photo match confidence. Although the customer has a strong account history, the identity verification issue requires further investigation before making a final decision. So as you can see that it is doing a very good job in deciding whether to escalate or to actually declare whether the transaction is fraudulent or not. Now, let me also give you a side-by-side comparison of the traditional machine learning algorithm versus agentic AI solution. So in a traditional machine learning, the inputs is only structured data. But in case of agentic AI, you can have all the structured features as well as unstructured evidences. The output of machine learning model is basically a probability plus some SHAP attributions. But in case of agentic AI, the output is the probability plus the SHAP, which is the reasons of the probability. And also it has got the natural language rationale, which is citing all the different evidences which it has gathered from all the investigations. Handling gray zone cases, it doesn't handle gray zone cases, it requires human, but in agentic AI, yes, it can automatically handle these gray zone cases. Both are consistent, and the speed, however, for a traditional machine learning model is slow, but for an agentic AI, the speed is very, very fast. And if you want to audit a traditional machine learning model, you just have the SHAP values. But in case of agentic AI, you can use the SHAP values. Plus, you can also do a full step-by-step evidence trial of looking at all the evidences which the agent has collected. So the key takeaway is that the machine learning model is, of course, the first line of defense. It is fast, it is cheap, it is consistent, and the agent is not going to replace it. But machine learning model can be used for all the cases which have a very high probability of a fraud. But an agent is very useful when all the use cases which fall into a gray zone, which requires a manual investigation. So this, you can replace it by agent because it can look into all the different structured data as well as unstructured data, and it can do an investigation exactly like human, and this kind of closes the gap for all the transactions which are falling in the gray zone. So hopefully you like this video. If yes, please consider subscribing to the channel as well as liking the video, and let me know in the comment below in which fraud prediction use cases you think agentic AI can be useful. Thank you for watching and see you soon in the next video. Bye.